Okay, guys, as we move on to 4-4 and 4-5, they're very similar to each other. I'm going to do two videos. I'm going to do one video that shows you how to factor using the box method, and I'll do another video that shows you how to do it using grouping. Miss Miles and I prefer the box method for students, and I think Miss Shirey and Mr. McBurney prefer grouping. So again, you can pick whichever way you like. Just watch that video and make sure you're very good at it. Step 1, no matter which way you pick. Identify A, in this problem it's 1, B is 6, and C is 8. And I need you to multiply A times C to get 1 times 8, which is 8. Then what I need you to do is I need you to find out two things that multiply to this number right there, that 8, and add to that magic number B up here, 6. Okay, so multiply to 8, add to 6. If you're not very good at this, just start with like 1 times 8. Well, that doesn't make 6. 2 times 4. There you go. That makes 6. So you know you found the magic numbers. And I'm going to teach you the box way first. Make a box right here. The first term, which was x squared, goes in this box. The last term, which is positive 8, goes in this box. These two that you just did, this 2 and this 4, they go diagonal from each other and they each get an x. And yes, they can be switched. Now hopefully from Algebra 1 you're very good at finding a GCF. Working your way down right here, I hope you see that there's a GCF of x. Moving your way down right here, I hope you notice there's a GCF of 4. Moving your way across right here, I hope you see a GCF of x. And moving your way across right here, I hope you see a positive 2. That factors to x plus 2 and the bottom x plus 4. Since all we're doing is factoring on this problem, that's the end of that problem. We're going to try that again. Please notice in these past two problems, there has been no overall GCF. So we move straight to finding A, B, and C, which isn't hard for you because you've been doing that in 4-2. All right, so we are going to make AC equal 2 times 5, which is 10. All right, and then we're going to pause. I need to find two numbers that multiply to that 10, but add to that middle number of negative 11. The only two, well, a lot of kids might think, well, 2 and 5, but that doesn't make 11, does it? The answer is 10 and 1. Now, granted, 10 times 1 is 10, but it's positive 11 when you add. So you just need to make them both negative in order to get your negative 11 and your positive 10. These are your two answers. Move to your box. When you move to your box, you put the first term in the first box, 2x squared. You put the last term in the last box, positive 5. You put these two numbers that you just figured out, like the pieces of the puzzle, here and here with an x. Yes, they are allowed to be switched. You pull a GCF out of the top row. So a GCF here is just x. X is the only thing that goes into both of those. You pull a GCF out of these two. Now this is negative, so you will be pulling out a negative. If the first one is negative, you pull out a negative. And the number that goes into both of those, a minus 5. Do the same thing going down. These you can pull out a 2 and an x. A 2 goes into both of them and an x. On these ones, the only thing that goes into both of these two terms is a negative 1. And we use a negative because the top one of the first one was negative. Since all we're doing this problem is factoring, we have our answer of x minus 5 and 2x minus 1. Oh, 2x minus 1, excuse me. Notice I did have this set equal to 0. I had done the problem more than I needed to, so you can totally ignore the fact that that was set equal to 0. I should have just done it without that in the very beginning. So your final answer in factored form is x minus 5 and 2x minus 1. What I need you to recognize on this problem is that there is a GCF. And I have a lot of explanation points because I was hoping that you would see it. I hope you know that 3 is a GCF of this problem. When you pull out a 3, you divide. So this turns into 2x squared. This turns into 3x. And this turns into minus 2. I'm not going to solve this one. We'll just factor it. So our final answer will have a 3 out in front. So I'm going to actually do that so that when I get my parentheses, I don't forget my 3 out in front. We're going to go ahead and find A, B, and C now. You will not use these original numbers anymore. So we need to do A times C, which is 2 times negative 2, which is negative 4. Now I need to make my little chart. I need things that multiply to that negative 4, but I need them to add to my middle term, which is 3. You might think of 2 and 2, or maybe 2 and negative 2, but that does not add to 3. You might think of 4 and 1. Now in order to get that to multiply to negative 4, I need this one to be a negative 1. So when I multiply these two numbers, I get negative 4, and yes, it will add to 3. It's almost like a little puzzle you have to figure out. Now I'm going to draw my box. You put the first term, 2x squared, in this box. You put the last term, minus 2, in this box. And you put these two magic numbers you just figured out catty-corner from each other. And they each get an x. You're almost done factoring. Pull a GCF out here going down. So you're going to pull out a 2 and an x. Pull a GCF here out. Now you're going to pull a negative out because the first one's negative, and the only number that goes into both of them is 1. Working your way across, the only thing that goes into both of these is an x. Working your way across, I see a negative in the front, and they both have a 2. You are done factoring now. You put one side in one parenthesis and the other in the other. It doesn't matter which one, those two can be reversed. So that is just the factored answer. Let's try that again in number 20. Notice in number 20 there is no GCF. So we're going to practice this box thing one more time. You identify A, B, and C, and we need to find AC. AC is 2 times negative 3. That makes negative 6. Okay, so I need to make my little chart. I need to find two numbers that multiply to negative 6, but they need to add to that B value up there of negative 5. So maybe you're thinking, what about negative 2 and negative 3? Well, negative 2 and negative 3 does make negative 5 when you add it, but it doesn't make negative 6. I need a negative 6 when I multiply, not a positive 6. So the answer will be a negative 6 and a positive 1. That makes negative 6 when you multiply and negative 5 when you add. Now I go to the box. In the top left, you put 2x squared. And in the bottom right, you put that big minus 3 from the back. Catty corner from each other, you put that 6 and that 1 that we found. And they each get an x. It's time to find your GCFs. Going down, I see a GCF of 2x. They both have a 2 and an x. Going down here, the only thing they both have in them is a positive 1. And again, that's positive, so I bring down a positive. Now go left to right. These have an x in common, and these have not only a 3, but because the first one's negative, a negative 3 in common, a GCF. It's time to put them in a factored form, x minus 3 and 2x plus 1. Now again, if you're wondering why I'm not doing that extra step of solving, it's because remember up here I said, let's pretend they're equal to 0 and let's solve them. But if all the directions say is factored, this is as far as you need to go. Number 26. I hope you notice that everything below this line is different. All of these problems are 2 terms. Please notice all of these problems are 2 terms. Okay? Sorry, I didn't mean not to show you. All of these 3 right here are 2 terms. These are special cases. I hope you remember from Algebra 1 that when you have, this means the difference. See how it's a subtraction sign? This is the difference of each of these perfect squares. When that's the case, you just go straight to your factoring and you take their square roots. The square root of x squared is x and x. The square root of 64 is 8 and 8. One's a plus and one's a minus. If you want to check if you're right, you distribute those back together. But I promise that when you have the difference of perfect squares, it's as easy as that. 28. Please notice again we have the difference of perfect squares. Both of those numbers are perfect squares. When there's no GCF either, okay? So you take their square roots, 5x and 5x, because the square root of 25. The square root of 1 is 1 and 1. One's a plus, one's a minus. Number 36, you might not see it, but there is actually a GCF in number 36, and it's because of this first thing being negative. The GCF is negative 1. So before I do anything, I need to pull out a negative 1. When I pull out a negative 1, that gives me positive x squared minus 196. Notice now I have the difference of perfect squares. The negative 1 goes in the front, and we just had to find their square roots. The square root of x squared is x and x. The square root of 196 is 14 and 14. One's a plus, one's a minus. And that's all there is to the difference of perfect squares. Now I want you to notice that down here we have 4 terms. 4 terms are actually easier than 3 terms. As long as there's no GCF, they're ready for the box. Notice on this problem, there is no GCF. Because of that, you put it straight into a box. You put 3x squared here. You put the first term there. You put the last term where you're used to putting the last term. And then these two it doesn't matter which one goes where. So you can do plus xy here and minus 12x here. Notice I did not make you find A, B, and C. We get to skip this entire step when you have 4 terms. The GCF going across this way is a 3 and an x. And the GCF going across this way is a y, a positive y. The GCF going this way is a positive x. And the GCF going this way is a negative 4. Goes into both of those numbers. This problem is ready to be factored. 3x plus y and x minus 4. You should do a quick check just to double check that this is correct. For example, this would be 3x squared when you distribute. This would be a xy, so we're checking it out. This would be a negative 12x, and this will be a negative 4y. Number 6, please notice there is no GCF to take out. We're ready to go straight to the box because it's a 4-term problem. B cubed there, negative 6 down here. These two can interchange. It doesn't matter where you put them. And now you pull out their GCFs. Going down, I can actually pull out b squared. Not just b, but b squared. Going down, I can actually pull out a negative 2. Not just a positive 2, a negative 2. Going across, I can pull out a b. And going across, I can pull out a positive 3 because the first one's positive. Now we're going to write our answer and check our answer. That's b squared minus 2 and b plus 3. You should, with these 4 terms, always do a double check if you were to distribute them together. So b squared times b would give you this b3. 3 times b squared would give you that 3b squared. Negative 2b and a negative 6 when you distribute. The back deals with solving. Like the first step you need to do, guys, you have to have it set equal to 0. Okay? Step 1, set equal to 0. So I'm going to keep the 2x squared here. I'm going to bring the 7x over by subtracting it and bring the 4x over by subtracting it. Now it's set equal to 0. Please notice there is no GCF. at all. So I move on and I do, it's 3 terms, so I have to do A, B, C. 3 terms is A, B, C. Please note that AC is 2 times -4, which is -8. Now I'm ready for my little chart. I need it to multiply to that -8 that I just found. And I need it to add to, don't look up here anymore, I need it to add to that middle term of -7. You might think -4 and 2, but that does not add to -7. Okay, the answer is -8 and 1. That will add to -7. And that comes with practice, guys. If you're struggling with that part, that just comes with knowing your multiplication tables. Put the first term, 2x squared, here. Put the last term, -4, here. Put these two catty-corner from each other. Each one gets an x, or whatever variable the problem has. Going down, you're going to pull out a 2x. Going down, the only thing that goes into this one is a +1. And I say +1 because that was a positive. Going across, I can pull out an x on the top. Going across, I can pull out a 4, but just not a 4, a -4. Don't just pull out a 2. You got to pull out your greatest common factor. This is now factored to 2x plus 1 and x minus 4. You set each one of these, now that the directions say solve, you can't stop. You set each one equal to 0 and use your Algebra 1 skills. So you do 2x plus 1 is 0 and x minus 4 is 0. Take away 1, take away 1. 2x equals -1. Divide by 2, divide by 2. X equals -1/2. That's one solution. Add 4 and add 4. That's just going to be x equals 4. That's your other solution. Number 8. We have to set it equal to 0, which we do. This is a very special problem. Please notice that this problem does have a GCF. That always needs to be your first step. It is a 2 and an x. Yes, it was set equal to 0. That's important to note, that it should be set equal to 0. Let's pull out a 2x. We're going to be left with dividing by 2 and by x, we'll be left with an x. Dividing by 2 and by x, we'll be left with a 5. So you divide each term by 2 and by x. Notice this is not a trinomial, so we do not do a, b, and c. Notice these are not perfect squares. I'm going to write that down. So this is not a trinomial, and it is not perfect squares. So it is ready to be solved. You set this part, this one was nice and easy. Set this equal to 0, divide by 2, and set this equal to 0. Minus 5. So you get x equals -5. Your two answers are 0 and -5. This was a special problem because there were only 2 terms and it was a GCF problem only. It was not a box problem because there was not, since it was not a trinomial, it's not a box. Can't have a box if it's not a trinomial. All right, number 10. Please note that it's set equal to 0. That's an absolute must. It has to be set equal to 0. There is no GCF in this problem. Now we're going to move on. We have A, B, and C. AC is 3 times 2, which makes 6. So now I set up my chart. Multiply to 6. Add to my B value of -5. Let's see, we know 2 times 3 makes 6, but 2 plus 3 makes a +5. If I change those both to negative, that still gives me my +6, and now when I add them, it gives me my -5. Set up your box. Put 3x squared in your first box. put the +2 in your last box. Put these two numbers that you found catty-corner from each other with an x, or whatever variable the problem is using. Pull a GCF out here. The only GCF is an x. Pull a GCF out here. That's kind of an odd one. The only thing that goes into them is a 1. And because that's a minus sign, I need a -1. The GCF on the top going across would be a 3 and an x. Positive, because the first one was positive. Going across the bottom, I can pull out a 2. And because the first one was a 2, that's a -2. This problem can now be factored. So we have 3x minus 2 in one parenthesis and x minus 1 in the other parenthesis. Set each equal to 0 and solve. So 3x minus 2 equals 0 and x minus 1 equals 0. Add 2 on this side. So you get 3x equals 2. Divide by 3. X equals 2/3. On this one, add 1 to both sides, and x equals +1. These are the two values that, if plugged into here, will give you an answer of 0. Number 18 and number 20, you do have to set them equal to 0, but we are going to use a calculator because it asks us to solve by graphing. So let's first put them equal to 0. So minus 2x minus 4 equals 0. Move those to the other side. I'm going to show you the buttons to push. But you know what? Let's do this tomorrow in class so you can actually learn how to push the buttons yourself.